Okay.
Hi, if you're joining us, thank you so much for joining us. I'm so excited to have you guys with us today. I can't believe we have 76 families that are going to do science with us, and that is like my life's mission. So I'm super happy about it. Tell all your friends it's never too late to join up, and anybody who joins up right now can still do all of the week's projects. So everybody should come join us. And I want to do a little bit of housekeeping just to make sure that you subscribe to the YouTube channel that we're on, because this is where we're going to do our live classes every day, and we'll do it at 11:30 Pacific time. And I'll have my two girls. I have a kindergartner and a fourth grader. So we'll do all of the projects live with them, and you can see how it sort of scales between ages. My kindergartner obviously needs a lot more directed help, whereas my fourth grader is very, very independent in learning and trying things and recording her own data. So subscribe to make sure that you get notifications so that you'll know when we're going live, and because you don't want to miss anything. And if you want to help us reach more people, give us a thumbs up and just give us a little bit of space and grace, because this is all new. I'm used to being in a classroom setting with kids, and it's totally different talking to a camera. I'm really excited for this new thing. I'm really excited to be reaching into your living rooms. But the IT thing might take a couple days to sort of get ironed out. So just give us a little space and grace on that. Okay, so let's talk about this week. I am so excited. So let's talk about what's in store. On that blog post, there was a zip file of week 1. And inside that file, there's a whole bunch of files. I'm going to organize it the same way each week. So it has biology, chemistry, physics, Ozobot programming, paper circuits, and engineering, I think, are the sort of the files that are in there. And I'll drop new stuff in each week for you guys. So in our biology this week, we open that one up. That one is super extensive. It's a lab that I made for kids that I teach a while ago. And it's one that I love to do because we're going to make a mummy. And if you really want to dive deep, you have so many resources now at your tips to really dive deep into that. So if you have a kid who loves Egypt and Egyptian culture, you can really just go all out with this one. You can learn how to write in hieroglyphs. You can carbon date some stuff, so you can make a little mass spectrometer in your house. Now, to make the mass spectrometer, that stuff's not on our supply list, but if you have wooden blocks and a hairdryer and pennies and nickels, you can do it at home, and I'll send you the links on how to do that, which is really cool. But tomorrow when we're live, we'll sort of talk about what is osmosis and how does osmosis make mummies. And our mummies are going to be, you're going to choose what you want. So maybe like an apple slice or a banana or a chicken drumstick. We've done a whole chicken before, which was amazing, and it truly mummifies, which is so cool. I would suggest steering clear of things that are already high in a salt concentration, so like hot dogs that have a lot of salt. And I say that because the way osmosis works is like you put your little chicken drumstick inside of a huge bag of salt. And the water in there inside your drumstick is like, oh my gosh, there's a salt party out there. We can't have a salt party. There's too much of one thing out there. We have to go dilute it. We want everything to be equal. Like the water, it loves to have everything equal. So it sees itself and has all this water in the chicken drumstick and all this salt out there. And it's like, we got to go dilute that. So it leaves your drumstick into the salt. And then every week, what you'll do is you'll change the salt. And so you'll get new salt, and that salt can absorb more water. And you're slowly drawing water out of that drumstick or that tomato or whatever you choose to do through the process called osmosis. And if you do something that's high salt, well, then you sort of have like a high salt hot dog in a high salt environment, and it will shrink and shrivel a little bit, but you don't get like as cool of an effect. And you might be wondering, okay, wait, how many weeks do I need to have this like mummifying chicken drumstick in my garage, which is where we put them, but you could put them in like a dark spot, like 4 or 5 weeks. However, your next question is probably like, my house is going to smell disgusting, and it's not. So that's kind of nice. The way that you make it, when it's such a high salt concentration, we add some baking soda, which is the sort of a mixture that the Egyptians used called natron. And that prevents bacteria from growing because it is so high salt that the bacteria can't actually grow there either, because bacteria are sort of like little like, blobs of water with DNA and all that gunk in it. And when you put them in salt, guess what it does? The water says, oh my gosh, there's all that salt around there. I should go out there and dilute it. And it leaves a little bacteria. And so it can never create smells, which is great. So that is one of our projects, is to start the mummification. If you want to take observations over time, that lab book will help you do that. So you can either take observations by just looking at it and recording what you want to see. And that's something that is perfect for a younger child. So younger kids have a really hard time sort of like seeing data, or like seeing sort of the value of taking data, one data point at a week. But they can really look at like, oh, but I noticed this change in the look. Or you could take measurements, like how long is my drumstick? What is the circumference of my drumstick? Or you could take other measurements, like how much does my drumstick weigh? And in fact, there's a graph in that lab book for you where you can graph the weight of your drumstick or your tomato or whatever it is over time, and you can actually see how much water is leaving. And sometimes it is very shocking about how much water is leaving. So that's a project we'll start this week. And then every week sort of going forward, you're going to want to change that natron, that salt and baking soda mix, and do your observations, record it in that little journal, and it'll mummify over the course of our enclosure. We'll mummify the coronavirus at the same time. So Tuesday, we are looking at some physics, and I am super stoked about the physics we're doing. I actually did this with some local 4th and 5th graders recently, and they had so much fun. And the first one we're going to do is maybe one of my favorite activities of all time, because when I was teaching this in the class, all the kids who have come to after school science with me were like, all right, Dr. Erica, we're going to stick with you because we know you do cool stuff, but we're going to do a whole day of science with literally Post-it notes. Like, are you kidding me? And I was like, no, trust me. And then there was the kids who had never had me before, and they were like, I'm not buying this lady. Like, what is she doing? And probably 10, 15 minutes later, everybody was like squealing, running in and out of the building because we had to go find rocks, and it was just completely crazy. And it's because our Post-it notes, we're going to interleave them like, so like if this is like the sticky part, and here's my little leaves of paper, we're going to sort of shuffle them like this. And we're going to learn about forces before we do it. And we're going to learn about the force of friction, which from one page to another is actually not very much. And maybe if you have 2 pages of Post-it notes, also not that very much, not very cool. If you have 40 pages of Post-it notes, you can actually it's pretty hard to take apart. In fact, my kids got 65 pounds hanging between the Post-it notes when there was 40. And when it broke, it's because our C-clamps slid off of the Post-it notes. So we couldn't actually rip the Post-it notes apart with what we had. And that's why it's so exciting, because it's something that seems so like minor, something you don't really think about, and it just adds up to being such a major effect. And if you don't have C-clamps by Tuesday, that's totally fine. What you can do is you can do a tug of war. So I have like 5 Post-it notes, I think, interleaved here, and you can try to sort of pull the 5 apart. And if you get it right, it'll come. But when you get 40 together, it's going to be really difficult to do that. And one of the things that I love asking the kids before we do the experiment, as we're talking about forces and friction and all of those things, is, do you think friction can be really, really strong? And do you think, like, if I was going to do this project, not with Post-it notes, but with, say, like a phone book, do you think like it could lift me? And of course, everybody's like, no way. And I'm like, all right, well, like, so you don't think it could lift the car either? And they're like, no, it can't lift you. It certainly can't lift the car. I'm like, yeah, that's totally true. And I take sort of this vote, and when you put it up on the board, it was like 0 to 12. And then over the course of doing the project, of trying it out, of trying to rip it apart or adding weight into buckets between the Post-it notes, every single person changed their hypothesis about whether or not phone books could lift a car. So don't tell your child this, because you'll totally ruin that like exciting moment of when they think one thing and they do a little bit of science and they realize like, I need to update my guess because I have more information and I think it actually could do it. And we can then watch videos of phone books lifting a car, which is so cool. And then we can watch semi-trucks of ripping them apart. And it actually took like a little bit more than 4,000 pounds of force to rip the 2 phone books apart. And even then, it wasn't friction that gave, it actually just ripped the paper. So that is a really cool one that I'm super excited to do. It's so simple and so powerful. And the other thing we're going to be doing with physics is once we talk about forces, we can start talking about energy. And so we'll make little energy rollers. And I love talking about sort of potential energy and kinetic energy. So when we talk about potential energy, that sort of is like you're giving something the potential to move. So like if I pull back a rubber band, I'm giving it the potential to fly. Or if I pick this up, I'm giving it the potential to fall and go really fast. The farther I pick it up, the more potential energy I give it, the more potential it has to go really fast at the bottom, which is sort of an easier way for kids to understand that dynamic of potential energy to kinetic energy. And then to see it in action, what we're going to do is we're going to build these little rollers, and they have a rubber band strung through the middle, and you wind the rubber band. So we're not stretching it to give it the potential. We're actually twisting it to give it the potential. And when you wind it enough, of course, it wants to unwind really quickly. And what will happen is it'll unwind and it'll start pushing your little roller forward. So you get a little sort of car that's made out of Solo cups and CDs and rubber bands and popsicle sticks, which is pretty awesome. And once you have that made, you can start doing really fun things. If you have 2 kids, you can do races. And if you just have 1 kid, you can do time trials. You can do experiments of like, how many turns do I do my popsicle stick? How many twists in that rubber band? So I'm adding more potential energy as I twist that rubber band more. Does it go faster? Does it go farther? You can start checking out those things at home, which will be really fun. And kids love to build. So that right there, hands down, like you're building something that's moving, which is fun. And then Wednesday, we're going to put our engineering hats on, but we're also going to keep talking about energy, and we're going to do it with an egg drop. So we're going to drop an egg, and their goal is going to be to save that egg. I like to do this with a raw egg. All of the classes I've taught, we've always used raw eggs. I just kind of feel like hard-boiled eggs, it's cleaner, but it's also not as exciting because when you try something and it splats, you're like, oh my gosh, it splatted, ah, right? So that's awesome. But of course, there's the mess. And what I do for that is I actually put the egg in a Ziploc bag, and then they build their engineering creation around that, and then they drop it. So you can then take it apart and you can check it. And if your egg is good, no mess. And if your egg is completely smashed, still no mess. It's a win-win. So there's a few challenges, and in your download, you have a lab book that you can learn some of the vocabulary. If you want to really dive deep, you can learn about vocabulary, and you can get a ton of information about how you're going to do it. It has a place for you to sketch out what you think you're going to do for your model. And you can scale this for kids. So younger kids, you can just say, here's your recycling bin. Go for it. Whatever you want to do, you guys should figure out where you want to drop from to do, decide on something that's going to be the same every time. So when you fail, you can retry it and see if you did better. And then if for older kids, you can say, all right, we're just going to use popsicle sticks this time, or you only get to use these straws, or you only get to use, 10 meters of tape, or you only get to use toothpicks. And you can totally do it with just toothpicks. So I actually work my summer camps at an observatory. It's 3 stories tall. And every year on our mission to Mars, we have to land our little egg rovers on the surface of Mars, which is the grass below. And they drop it from the roof all the way down. And we have levels. So they have stages where you can build with anything, and then you have to build within a certain volume, and then you have to build with just toothpicks. And they have survived a 3-story fall with just toothpicks. So totally possible, and a great challenge if you have older kids or kids who just love to build. So that's what we're going to be doing on Wednesday. And then Thursday, we're going to jump into some chemistry, and this is a really fun chemistry experiment so that you're totally ready. What you're going to do is we're going to actually take a bowl of vinegar, cannot be a metallic bowl. It needs to be a plastic or a glass bowl. And you're gonna add a little bit of salt to it. And we're gonna dump some really old, grungy, gross pennies in it. And it is gonna clean it for us. Now, the vinegar would do it on its own. Vinegar is acetic acid, and that will clean the pennies on its own, but it sort of just goes slowly. It sort of like sloughs off the very top layer and just sort of like does it nicely. And when the salt's in there, it's like a jackhammer on that surface. It's like drilling holes into it so that the vinegar can get in and really get it all off. So it's going to go a lot faster with that salt, and you need the salt to be able to see it in our time frame. And then what you guys will do is you'll take those pennies out, and some of them you'll rinse, and some of them you'll just set aside and let it go. And you'll take your bowl of vinegar and salt solution. So this is in the instructions, but I want to say it now. Don't get rid of your vinegar and salt solution, because it's not just vinegar and salt anymore. Because to make the pennies shiny, it took the oxidation off of the pennies. And so you actually have copper ions in that solution. So if you dump it out, you can't just make vinegar and salt again. You'd have to do vinegar, salt, and clean some more pennies. But we have this solution that's vinegar, salt, and the copper that we stole from those pennies. And if you put a nail in it, the vinegar and the salt will do the same thing to the nail, to like sort of jackhammer the outside of the nail off. But instead of copper is a positive charge and the nail is iron, it'll be a negative charge. And they'll sort of, opposites attract, they'll sort of bind together, and you'll get a copper coated nail, which is super cool. And you'll have another little experiment you can do with the pennies. And there's going to be so many opportunities if they love that. You can do things like, what happens if after we do this treatment, we put pennies in ketchup? What happens if we soak pennies in baking soda? What happens if we, bake pennies? I don't know. There's all of these different things that you can try if they're really into it, and just sort of go with it and let it go, let them lead you. And then Friday, we are going to start paper circuits. So I don't have one with me at this exact moment, but this is like a little paper circuit bookmark that we've made. And the way it works is there's a little CR2032 battery, the little coin cell batteries that you see in your keychains. And then underneath this paper is actually some copper tape. And you might be able to see it at the top of this, but there's some copper tape and little LEDs. And we'll talk about how circuits are made, but the electrons are going to go out the top of the battery. They're going to come up, they're going to go through the LED and into the bottom. And the circuit is like a circle. So if when you're working with your child it's not working, make sure you've completed a circle. So go from the top of the battery through an LED into the bottom of the battery. And one thing to think about also actually is that LEDs are one-way streets. And I'll talk to this about the kids on Friday when we're doing it all together. But the LEDs, they like to slide down and woohoo! And when they go woohoo, they light up, which is awesome. But they're also way better rule followers than all of us. So if you're asking them to slide down and say woohoo, they'll look at the bottom of the slide and never climb it, which I know we kind of wish maybe all of our kids listened to that well, but they don't. Electrons listen great. I mean, man, never will climb that slide. So if it's not working for you, one thing you could try to do, and I'll mention this on Friday, is flip your LED over. And you'll get something fun, and ours is just going to be sort of like a blank piece of paper so that they can draw their own thing and create their own art. So that's Friday. And then if you want to dig even deeper with science, if that's not enough, which I would be like shocked because that's like so much amazing science and so much learning right there. But I do have some other options that are in there. We have Ozobot activities. And so if you are getting an Ozobot, they're these little tiny line following robots. They're about like this big. They are my favorite thing on the planet. You can draw a line and they'll follow it. You can draw a line and then put color codes in it and they will follow the color codes. So you could say like turn left and it'll turn left, or speed up, or do a twist and it'll do those things. And then you can take it onto like a computer or a Chromebook and you can program it with blocky programming. So they have drag and drop of go straight, turn right, go straight, turn left, and you put your little Ozobot on top of it. It has color codes, so it flashes colors, and then you put it on your thing and it does exactly what you wanted it to do. So I'll have some mazes to start off and sort of learn how to play with those Ozobots if you choose to do that. And then I also have Tinkercad. So Tinkercad is a 3D SketchUp program. It's very kid-friendly. It's basically sort of, I want a cube, I'm going to put a cube in my computer space, and then I want a circle that I'm going to put as a hole, and I'm going to group them together, and I have this like sort of square bead. If you're on Bainbridge Island, I can print some of these things for you. If you're not, and you don't have a 3D printer, you can always see if like there's online things that will print for you. There's also a lot of maker spaces or libraries will usually print for you, although who kind of knows what's going on with all of that right now, because this like whole world is closing down. So our Tinkercad activity will be measuring a pencil piece to make a pencil topper so that you can cover your little eraser and keep it nice and perfect. So we'll do sort of a little online training for that if you're interested in it. And then I have a fun little math snack project, and it's learning about sort of how exponential numbers are really important. So what you'll do is you'll take a plate, and you'll have your plate, and you can split it up into 8 pieces, and you'll put like a 1 here, and then you'll double. So 1 times 2 is 2, 2 times 2 is 4. And now kids, when they're doing this, they don't have to know their multiplication facts. They can just put like, we're going to do it with snacks. They can put like 1 blueberry down, and you say, put down twice as many blueberries in this spot, and then twice as many blueberries in this spot, and then twice as many. And they'll get a sense of how quickly exponents can really get out of control and fly away on you. And one of the questions that I asked with that math snack is, if somebody offered to pay you 1 penny to mow their lawn, but they promised that every time they mowed their lawn, they would double their payment, is that a good option or not? And this will help you realize that it's actually a pretty incredible option, because once you make $1, then you'll be making $2, and you'll be making $4, and then you'll be making $64, and then you'll be making $128, and it just sort of really goes up really quickly, and you'd be making, $10,000 for mowing the lawn once after like, a few weeks. So those are the projects that we have. The physics projects don't have downloads quite yet. I'm working on the arts and getting those pieces together because they're so new, but you should expect to see those obviously before Tuesday. And I guess if you do have questions, you can always type them in, and we will get like a little notification pop up. So if you have questions, I'm happy to answer them. What other things? I just gotta say, I'm super excited, man. I cannot wait to be doing this with you. I can't believe we have like over 70 families who are gonna do science. This is my passion and my mission in life, and I feel like I get to spread science. So I'm really happy about that. Let's see, do we have any questions?
It'll be recorded.
Oh, it'll be recorded. So if you don't make the 11:30, or you don't sort of see this like overall synopsis each week, you can always view it whenever you want. So you'll have access to that. And I'll be putting up a whole lot of video links, because a lot of these projects I've done and I have sort of tutorials on. So you'll get a lot of online video tutorials too, which will be very handy. And
do they have any questions? Ask some questions. Anybody watching have questions?
Anybody who's watching have questions? Let us know. And if not, we'll get started tomorrow. Fun. I'm so excited. My girls are so excited because this Post-it note one, my 4th grader was like legitimately angry at me that she did not get to do it because she was in school, and she asked to skip school to come to the other school to do the project. So she's going to be very excited about doing that one on Tuesday. But
so somebody asked, what ages do these apply to?
Great question. So I teach mainly kindergarten through 4th grade when I'm in after school. And kindergarten really needs a little bit more scaffolding. We need to just change our expectations. So personally, I think plant the seed and watch it grow is awesome. But I'm much more like, how many more activities can we do with that? So that just means that the younger kids need a little bit more scaffolding to help them make those things or help them make connections. The older kids usually do great. So my daughter's in 4th grade. I teach 5th and 6th graders a lot. But once you get sort of like in the upper middle school area, you're sort of getting outside of my realm, just because we're much more maker-based and much more sort of like, let's get the oohs and the ahs and keep your interest in here, and less of like, let's do the math and that kind of thing. So I would say probably K through 4 definitely, and then like a 5th, 6th is like, they would have a lot of fun with Tinkercad and Ozobots and a lot of the projects, but you're going to sort of wane off after that.
Right. There's a question to How are we going to demonstrate at 11:30 that we're ready to go?
Ooh, great question. I'm probably just going to go for it at 11:30. So if you're all set up, it's going to be a live YouTube video like this. And then after that, we're going to get onto a Zoom classroom where if you've had trouble, you can sort of hold up your projects and show me. So like paper circuits is a perfect example of that. We'll go through it and I'll teach you guys how to do it and you can do it with us. And then after that, you can get onto our Zoom classroom and be like, my paper circuit's not working, like what's going on? I'll be like, no, I'm looking at it and I'm seeing like a little tiny crack in your copper tape right there. Did you fold it or did you cut it? And oh, I cut it. Oh, okay, that's your problem. And like, why don't you try this? So that'll be after. And then like, yeah, right before it'll just be me and my daughters and probably my husband once we get all the IT figured out, just doing the projects and explaining it to you and showing you how to do it. And kids can do it along with us, or they can just watch it happen and partake in the science that way. It's sort of up to you.
And we'll send out links for that we're live and stuff to remind people. Yes,
we will have, we'll send out links and you can just mark your calendars. At 11:30, we should be live every day, Monday through Friday, which is exciting. You have any other questions?
No other questions? Last chance?
Awesome. Last chance for questions. This
will be recorded so you can review stuff.
It's true. It will be, so we can all, it'll be fun. And hopefully in some of the future ones, when I have a little bit more time, because this past weekend was all just getting all of these logistics up and running for you guys, I would really like to be able to actually do it with you right now for the whole week. But then it might also be like really long because we've been here for like an hour. No, only half an hour. Okay, it's not that long. That's doable. But we didn't do the projects, so maybe we'd be here for like an hour. I don't know. If you want that, we can do it. We can totally do it. I love doing science. All right. So there's no more questions. We will sign off.
Sure.
Don't forget to subscribe to our channel so you don't miss the notifications, to share our message, make sure you get all your downloads ready and pass the word along. And we cannot wait to see you tomorrow. Have a great one.